Hello, today we are going to discuss is about the old model question paper math module 1 first question A. For 6 marks they have asked this question: derive Cauchy-Riemann equation in polar form. So what is the statement you have to write and also the proof. Statement is the necessary condition that the function w equal to f of z is equal to u plus iv is said to be analytic function, then there exist 4 first order partial derivatives which are dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta, such that dou u by dou r is equal to 1 by r dou v by dou theta and dou v by dou r is equal to minus 1 by r dou u by dou theta. Till here if you write is also more than enough, or still further also you can extend u r is equal to 1 by r v theta and v r equal to minus 1 by r u theta. If you take this r over there, we want in terms of u and v. So r u r equal to v theta and minus r v r equal to u theta. So no need to write till these two steps also, you can skip. Till here is more than enough. Now let us try to understand this statement. When do we call it as a analytic function? So any function, what is a function? Function is nothing but some operation we are going to do, some statement will be there. For that we have to do some kind of operation and we will get some result. The necessary conditions that the function w equal to f of z equal to u plus iv is said to be analytic function. For a function to be analytic, okay, what function we are taking? Firstly we will take one variable w. As we are taking it as a function, let us call it as f of z. F of z is equal to u plus iv. Why? Because we are taking complex numbers. Complex numbers can be represented as what? X plus iv or u plus iv, where we will have complex number with real number and imaginary number. If any variable associated with I, we call it as imaginary number. This is real part, u is real part and v is imaginary part. For this condition, for this function, this is a normal function now. Okay, u plus iv is a normal function. For this particular function, if it has to be analytic, then what should we do? What should happen is, it should exist 4 first order partial derivative must exist. How many of partial derivatives? 4 first order partial derivatives must exist. Now what is partial derivatives? We will do differentiation only with respect to whatever they are telling. We will concentrate only on that. Okay, like if we are telling that differentiate with respect to r, wherever r terms are there, that particular thing only we will differentiate. With wherever there is absence of r, we will not at all bother about that. Okay, in the proof we can check over what are those first 4 partial derivatives. They are dou u by dou r. What is now dou? Dou is nothing but whenever dou is represented for the partial derivatives. Okay, as we are doing only partial derivatives, this is a symbolic representation. Dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta. So these are the 4 first order partial derivatives we should have in order to for a function to be an analytic function, such that first thing is 4 first order derivative must exist. Now they are existing. Secondly, how they are should exist means dou u by dou r is equal to 1 by r dou v by dou theta and dou v by dou r equal to minus 1 by r dou u by dou theta. This is what we are going to derive now. Okay, and as I told you, these 2 steps if you want you can skip. Nothing. U r is equal to 1 by r v theta, v r is equal to minus 1 by r u theta. This dou u by dou theta is represented in these terms, that's it. And if you take cross multiply, it will become r u r equal to v theta and minus r v r equal to u theta. Now let us see the proof. What is the proof? Since w is equal to f of z is analytic at z equal to r into e to the power of I theta. Firstly, what is this w? W is, what is w? We have taken here, right? We have taken the function w is equal to f of z. We have taken. Start from that only. We call this particular function is analytic at z equal to r into e to the power of I theta. Now from where did you get this r into e to the power of I theta? Means complex numbers can be in Cartesian form or polar form. Polar form means we represent the complex number in r into e to the power of I theta that we have studied in the previous semesters. Okay, as of now what you should remember is, if at all you are talking about polar form, z will be in terms of r into e to the power of I theta. Okay, now take w equal to u plus iv and z equal to r into e to the power of I theta. Why you are taking u plus iv? Because it is a complex number. Okay, and this is bipolar form. We can take it as z equal to r into e to the power of I theta. Now what we can do is, with this equation, this w equal to f of z, we are going to substitute for w and z. So in place of w, just substitute u plus iv is equal to, as it is, you take the f function, in place of z write down r into e to the power of I theta. Take it as equation 1. Now what are we going to do is differentiating partially with respect to r for equation 1. With respect to r only you have to differentiate. How we can partially means you should use dou, right? So differentiating means wherever there is no r terms, what you will do? Just write dou u by dou r. Why dou r? Because we are doing it with respect to r. Dou u by dou r plus I into dou v by dou r is equal to, f will become f dash, okay, and r into e to the power of I theta. So what actually here happens is, r is not a single thing here. R is it is in terms of r into e to the power of I theta. Then whatever is associated with the r, that we have to differentiate again. What is associated here with r? It is e to the power of I theta. Okay, if at all only e to the power of I theta, if it was there, what would I have done? We have to write divided by the dou r. Then first take this as equation 2. Nextly what we are going to do is, again for the equation 1 we are going to do with respect to the theta. Right now we did with respect to r. Secondly, now we are going to do with respect to theta. Let us check this equation. With respect to theta means, what will be the first condition? Will become dou u by dou theta plus I into dou v by dou theta is equal to, f will become f dash. R into e to the power of I theta will be the r into e to the power of I theta. Now see carefully, as we are doing with respect to theta, theta is in terms of power, right? So whole thing, whichever is included, whichever is associated with the theta, we have to differentiate again. So that is why we are taking as r is a constant, we will take as it is, and e to the power of I theta is nothing but I into e to the power of I theta. We know that, right? We have the formulas. So that is how we got r into I into e to the power of I theta. Take it as equation 3. Now again what we are going to do is, using equation 2 in equation 3 we get. So this is our equation 3. In this equation 3 we are going to substitute whatever we got in equation 2. What you got? See, firstly equation 3 you write down as it is. What is that? Dou u by dou theta plus I into dou v by dou theta is equal to, see, f dash of r into e to the power of I theta into e to the power of I theta, we have this one from equation 2. This is this f dash of r into e to the power of I theta into e to the power of I theta. Here we have now what is equivalent to that? Dou u by dou r plus I into dou v by dou r. Write down as it is, dou u by dou r plus I into dou v by dou r. Now you can see here we have substituted only for f dash into r into e to the power of I theta into e to the power of I theta. What about this ri? It is remaining, right? Write down as it is. Why did we substitute? Because we need in terms of u and v. That is why we are doing all this thing. Okay, is it clear to you all? Next, now what happens is dou u by dou theta plus I into dou v by dou theta is equal to, okay, see, now we have seen here, that is here you can see to that we got this equation. We have to multiply with r into I, right? This ri we should multiply for dou u by dou r, as well as we should multiply for I into dou v by dou r. That is what we are going to do now. Okay, so dou u by dou theta plus I into dou v by dou theta is equal to, we are multiplying that I into r. Ri and ir is one and same, right? So ir dou u by dou r plus I into ir. What is I into ir? That will become I square r dou v by dou r by multiplying ri throughout the equation. Now what we are going to do next is dou u by dou theta plus I into dou v by dou theta is equal to ir dou u by dou r. We have one formula. What is that formula? I square is equal to minus 1. What is I square? I square is equal to minus 1. You can substitute over here, minus 1 into r into dou v by dou r. Now next step is what you can do is dou u by dou theta plus I into dou v by dou theta is equal to ir dou u by dou r minus 1 into r. What is 1 into r? It is r itself, minus r into dou v by dou r. Now what we can do is equating the real and imaginary parts of LHS and RHS. How do we know that it is a real part or imaginary part? Only thing is, wherever if it is I is associated for that particular thing, that is imaginary part. Wherever there is no I, that is called as a real part. Now we can see here dou u by dou theta, okay, and minus r dou v by dou r, they don't have imaginary part, right? So we are taking it as one equation. Next is again what do we have? I you keep it as it is. Okay, don't write I now. You have to write only dou u by dou theta and dou v by dou theta. Dou u by dou theta is what? Minus r into dou v by dou r, and dou v by dou theta, what do we have here? R into dou u by dou r. I will remain there itself. Okay. Next, what can we do here? If you want in terms of dou v by dou r, minus r can be shifted downwards, right? So that will become minus 1 by r dou u by dou theta, and dou u by dou theta is equal to, again shifting same thing, 1 by r into what we will get? Dou v by dou theta. This can also be written as u theta is equal to minus r into vr. See, here it is there, no? You can remember like this, u theta equal to minus r. If we go to the side, it is rvr, and v theta is equal to ru, are the required equation.